So, good morning, dear student. In my previous class, I had discussed about the classification of surfactant. Today, I am going to discuss the second part of that chapter, that is the properties of surfactant. Now, there are many important properties, and out of these properties, I will discuss, of course, CMC, I will discuss about the craft point, I will discuss about the cloud points, and so many other things. But one of the most important property which is related to the application of the surfactant or emulsifier, and that is also one of the most important driving force, that is called, sometimes it is called hydrophilic lipophilic balance, or sometimes it is called HLB scale, or sometimes it is called HLB parameters. And if you understand these HLB parameters, so you can throw some light on the quality of the surfactants. That means, suppose you want to use some of the soap and you know the HLB value, so you can understand that how it works. So with the help of this HLB balance, you can identify the most cost-effective, user-friendly detergents, or even sometimes you can use for cosmetics and pharmaceutical industry. Even you can use also emulsifying oil. So today, very briefly, because I have to discuss other properties also, I will discuss this HLB balance. Now, as you know that it is my regular practice, whenever I start any topic, I always give some basic history of that balance. And for that, I must tell you that this HLB balance parameter or the scale was discovered by a scientist. His name is Griffin. He was working in the Atlas soap company or like that, Atlas oil company, and he actually discovered this HLB balance in 1949, and then of course he also determined this HLB balance of some non-ionic surfactant in I think 1954. But if you refer some of the good books and research papers, you can get all the information, and it is very important, as I told you, that out of most of the properties, it is very important for the industrial purposes. So you can refer this journal, and it is Encyclopedia of Biocolloids and Biointerface Science. Is a volume, and one chapter is given the hydrophilic lipophilic balance, classical induction and novel induction of surfactant. I have referred this journal. I have also referred this research paper for preparing this my short lecture, that is evaluation of hydrophile lipophile balance of non-ionic surfactants, and I have taken some of the data, because if you see the examination paper, you will see sometimes they ask, because the range is very high, the HLB scale is from 1 to 40, and depending upon the scale, suppose if the value is 1, what does it mean? If the value is very high, what does it mean? So I have taken some information from that research paper also. But as I told you that this is the original research paper of this William C. Griffin. So therefore, generally we called it Griffin model or Griffin scale, although before that, I think one scientist, Clayton, he also published some paper in 1936. But credit goes to the Griffin, and this is actually original paper. It is Journal of the Society of Cosmetic Chemists and published long back, 1949. And the classification is surface active agents is HLB, like that. And similarly, this is the second paper. When he calculated, I'll show you the values. Calculated some HLB values of some non-ionic surfactant. And as I told you, the Atlas Powder Company, he actually, I'll discuss what is the definition of HLB and how it is useful for the surfactant research and other things. And after this Griffin work, there is another scientist, J.T. Davies, and he actually determined the values, and that is a quantitative kinetic theory of the emulsion type, because you know that it is related to the emulsifiers. You know that emulsifier. So I have also referred his research paper, and I will show you some of the data I have taken from this Davies research papers. So first, you know that I have already discussed the surfactants means sometimes you all know that we generally call it a amphipathy, because there are two important parts, and name itself is a definition, because one part you know that polar head group, so naturally this is hydrophilic type of the groups, and another part that hydrophilic means water loving, and whereas lipophobic means you know that you can understand the lipid and other things, and if it is non-polar part, that is called the hydrophobic part. So there must be a balance between this hydrophilic and lipophilic group, and you can call it a with the help of this HLB valence, you can identify the degree of their hydrophobicness or hydrophilicness. What are the important role of these things? So that is actually called the amphipathy, because cationic group as well as the some, I'll show you these things. So depending on the molecular structure, because I'll show you the structure, because you can consider for cationic, you can consider for anionic, you can consider for deuterionic. So depending upon the structure, because if I take C12, if I take C14, if I take C16, you know that hydrophobicity is changed. And if the chain is very long, it is more hydrophobic. And that surfactant forms micelle easily. So that is the different thing. So this is called actually HLB, hydrophilicity and lipophilicity, lipid loving balance. Now why we are studying this first, these properties? Because you see there are large number of applications, not on in emulsion, detergents, wetting agent, solubilizing agents can be classified with the help of this value, and is also very important in drug industry, because solubilizing is a very important property. So it is very important in pharmacy as well as medical science, and I can call it is a most fundamental and important concept, I must say, and it is very useful, as I told you many times, the formulation of the surfactant and emulsifier, because if you are talking about the new generation surfactant, and that is based on these HLB properties, it must be user friendly, it must be non-toxic, it must be cost effective, it must be functional, very good, active, like that. It can easily clean the things. So you can call it, it explains the balance between, that means in one word you can call it is a balance between the water loving and oil loving parts of a surfactant molecule. And definitely these two properties influence the solubilization and the detergents. That is the simple definition, and I will show you that how that HLB parameters can be determined. Now I must tell you the I have taken this diagram from a very renowned scientist, a well-known Indian scientist, Professor S.P. Maulik. He is no more. Many times he visited our place. So I have using this diagram from HLB balance from one of his research paper published in the Current Science long back, 1996. So you all know that if I talking about the ionic things, so you know, and if it is and I can use say anionic surfactant. So you know that this is actually, I can call it is a hydrophobic, and this part called HF, hydrophilic. And if it is a, you can refer this Current Science, and I can use, if it is a non-ionic type of things, there is no head group, but here is also another type of things, maybe a polyoxyethylene oxide like this, because non-ionic is very important for this HLB value. So this is same thing, it is hydrophobic in nature, like B35 Triton X, so it is polyoxyethylene. So this is part is high. So this part is very essential, hydrophilic. And if I am talking about the deuterionic type of things, so you know that of deuterionic things. As I told you that this HLB valence parameter or the scale was developed by Clayton. But when I have seen the literature, I have seen that actually W.C. Griffin published two papers, one in 1949 and in 1954. Actually he have determined the HLB scale for different types of non-ionic surfactant. Of course, on the basis of their solubility, oil in water. So you can call that is a empirical parameter or empirical scale, because on the basis of several data, they have figured out the HLB balance. And of course, Graphene was working in the Atlas Powder Company. And I have also referred some of the other research article like J.T. Davies. So I would like to show you some of the HLB values of some non-ionic surfactant and the scale, and I have taken from that J.T. Davies. And of course, the basis is the use of emulsifier. And you all know that emulsifier is a chemical that stabilizes the oil in water emulsion. You all know that when we mix oil and water, it do not mix. But if we add some surfactant, so it will form the micro emulsion. Now this is some values of HLB, or you can call it is a classification of emulsifier according to the HLB values. And I have taken these values from two books. This part I have taken from Davies, a quantitative kinetic theory of emulsion type. So if you see the range, as I have already told you, that in some books the range is 1 to 40, but in some cases the range is 1 to 20. So if the range of HLB values is 3.5 to 6, it means it can be used as a water in oil emulsifier. If the values ranges from 7 to 9, it can be used as a wetting agent. Similarly, if the range is 8 to 18, it is oil in water emulsifier we can use. Similarly, if it is 13 to 15, so it is detergent. And 15 to 18 is the solubilization. And if the value is very low or 0 like that, 1 and 2, so it is more soluble in oil. And if it is value is very high, so you can call it is soluble in water. Now I have also referred another book, Tedros surfactant. So that another classification, that HLB by dispersibility. So if the range is 1 to 4, so there is no dispersibility in water. If it is 3 to 6, poor dispersibility. 8 to 10, it is stable milky dispersion. And if it is 10 to 13, it is translucent to clear dispersion. And if it is greater than 30, that means it is a clear solution. So with the help of this table, you can understand the various ranges of HLB scale or HLB values. Similarly, you can also see the HLB values of some surfactant. Of course, they have used mostly non-ionic surfactant like Bridge 35 or Triton-X or Twin 20 like that. And if you see the non-ionic surfactant where there is a polyoxyethylene groups, the range is in between 1 to 10 or like that, 1 to 13 like that. But in case of sodium lauryl sulfate, the range is 40. In potassium folate, range is 20. Twin 80, range is 15. That means you can throw some light on these values of the HLB, so some non-ionic surfactant. Now I am coming to that, what is the significance of that HLB values. So first significance, that means of course it is useful for the emulsifiers. If the value is low numbers, it indicates that solubility in oil. That means it is very, very lipophilic type of emulsifier. If the number is high, so high number indicate solubility in water, very hydrophilic. Same HLB value may differ in the solubility. So now the last part of this discussion is that how one can calculate the HLB values or HLB scale. So I must confess that I have referred large number of research papers and large number of books, and on the basis of these books and research paper, I have just summarized the method by which you can also determine the HLB values. Now first, I am using that HLB value of fatty acid esters of polyhydric alcohols such as glycerol monostearate, that can be very easily calculated. HLB equal to 20 minus 1 minus S divided by A. S is, sometimes we determine the saponification value or saponification number of some soaps. And similarly, A is the acid number of the fatty acid. So by that method, one can determine the HLB value. There are some other methods also that the HLB value of a non-ionic surfactant like polyoxyethylene can also be calculated by same method, but the formula is slightly different. Here HLB equal to E divided by 5. These are all, as I told you, these are all empirical scale. And this E is the percentage by weight of ethylene oxide. In some literature, the HLB value can be calculated with the help of molecular mass. Now, here HLB is equal to 20, 1 minus mH divided by mW. This mH means the molecular weight or molecular mass of the hydrophilic part, whereas that mW is the molecular mass of the whole molecule. So by that method also you can calculate the HLB. I have also referred one of the important research papers published in the Journal of Colloid and Interface Science, that is the calculation of hydrophilic and lipophilic balance of polyoxy surfactant by group contribution method. So it is like that. Of course, it is based on the Davis equation that HLB is equal to 7 plus summation of hydrophilic group numbers. In some books it is written the minus also, but according to this paper it is summation of hydrophilic group numbers plus lipophilic group numbers. So if we add this added with 7, so the hydrophilic HLB scale can be calculated. Now you can ask me, sir, what is the application of this HLB scale? As I have already discussed in the introductory part, it is very important and it is one of the fundamental properties, and because it reflects the degree of a molecule, means surfactant or emulsifier, being hydrophilic or lipophilic. So a balance can be calculated. And there are many applications in cosmetics, pharmaceutical science, even in medical science. So I am just mentioning some of the very important applications. That means it is used in the lipid-based drug delivery, cosmetics, pharmaceutical formulation, solubilization and the detergency. That means if you know the HLB value, so you can choose the most cost effective, very efficient and user friendly detergents, and of course the solubilization properties can also be enhanced by the C of that parameters, HLB parameters. So as per your course contents, you have to just study the fundamental aspects of the HLB. So in my next class, I will discuss the other properties of surfactant like cloud point as well as the craft temperature and CMC other things. Thank you very much.